Okay, in this video, we're going to be introduced to what a limit is. So start at the top, there's a little notation. The limit as x approaches a of f of x exists if f of x approaches the same output as x approaches a from both the left and the right. So let's look at this graphically here. In this first example, they're asking us to find the limit as x approaches 4 of g of x. So we see 4 on the x-axis here, and we're going to kind of trace along the graph coming from the left, approaching 4. What output does the graph look like it approaches? Well, it sure looks like it approaches an output of 3. Let's go ahead and see if the same thing happens from the right. So approaching the graph from the right, what output does our graph approach? Our graph approaches an output of 3. Since we approach the same value of 3 from the left and the right, the limit exists and it equals 3. The second question is something different. This has nothing to do with what's happening coming from the left and the right. This is just asking what's the output when we input 4 to the function. When we input 4 to the function, we get an output of 3. So g of 4 equals 3. Move to the right. Same picture, but now there's a hole at 4. But we only care about when we're determining a limit what the graph approaches. So as we're approaching 4 coming from the left, just like I traced on that previous graph, what output is it approaching as we approach 4 from the left? It looks like 3. Does it ever hit 3? No, because that hole there. But the graph is going to approach an output of 3. Does the same thing happen from the right? Coming from the right, does our graph approach an output of 3? Indeed it does. So the limit as x approaches 4 of g of x exists, and it equals 3, since that's the output it approaches coming from the left and the right. Now this is asking what is the output of the graph when g equals 4? Well, there's a hole there. The graph is undefined. So g of 4 is undefined. Okay, next graph, similar, except they now have this point down here at the coordinates 4, 1. So let's first find our limit, and at a limit, I don't care what's happening at the point, I only care about what's happening as we approach 4. So approaching 4 from the left and the right, our limit is equal to 3. When we're finding a limit, we only care about what it approaches, not what it equals. At 4, our output, remember, is down here at 1. So g of 4 equals 1. Okay, next graph. It's an absolute value function, f of x. So we want the limit as x approaches 2 of f of x. Well, approaching 2 from the left and the right, does the graph approach the same output? It does. It approaches an output of 3. So the limit as x approaches 2 of f of x is equal to 3. Now, this is asking for the output of the graph at 2. The output of the graph at 2 does equal 3. Okay, same graph, except there's a hole. Why don't you try these next 2 boxes, the one on the left and the right? So go ahead and pause the video, try those 2 boxes yourself, resume the video, and you can check your answers. Go ahead and pause now. Okay, I hope that your answers match mine, and if you need to get more information about how to do problems like this, you can go rewatch those last 2 examples since they're very similar to these guys. Okay, let's go down to the one on the lower left. This one's asking us, it's got some little bit different notation here. This is asking what is happening as x approaches 2 from the left. That little minus sign means coming from the left. So as we approach 2 from the left, this is called the left-hand limit, our graph approaches an output of 3. So the limit as x approaches 2 from the left of f of x equals 3. The next problem asks what's the limit as x approaches 2 from the right. That little plus sign means from the right. So we're going to approach 2 coming from the right, and there's a hole there. It doesn't matter that there's a hole. What is our output approaching? Our output is getting really, 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 really close to 2. Now let's go back to our original definition. the limit only exists if the function approaches the same output coming from the left and the right. Since we don't have the same output coming from the left and the right, our limit does not exist. We use the terminology does not exist when talking about limits. Let's go back to our graph and find f of 2. So if I look at 2 as my input and go up to the graph, I see that the graph has an output of 3. That's where I'm looking for the closed-in dot. Okay, the last example, I can tell that there's a vertical asymptote on the graph. You've taken enough math classes, you're familiar with graphs that have vertical asymptotes. So we're going to follow along this graph coming from the left, approaching 2. So as our graph approaches 2 coming from the left, the graph is going to go down off the graph at that vertical asymptote and approach negative infinity. Next problem asks what's the limit as x approaches 2 from the right of f of x. So approaching 2 from the right, the graph is going to go closer to 2, but as it approaches 2, it's going to go up toward positive infinity. Do the left and the right-hand limits equal each other? They do not. So we say the limit does not exist. In order to have the limit exist, we have to approach the same output from both the left and the right, and that doesn't happen in this case. Now in this one, at a vertical asymptote, the function is not defined there. So f of 2 is undefined. The graph does not exist at x equals 2. So this was our lesson on Introduction to Limits.